Okay, so I hope you all went through the lesson part for chapter 8, and then in this part I'm going to go through the worksheet with you. So go ahead and open the worksheet on D12 chapter 8 worksheet, and I'm just going to go through some selected questions. The rest I'm going to let you complete. So question number 1. Oops. Okay. Mileage tests were conducted on a randomly selected sample of 100. So that's your sample size. And newly developed automobile tires. The average thread life was found to be 80,000. So for those tested 100 tires, they found average is 80,000. That means this is your sample mean, X bar, with a standard deviation of 5,600 kilometers. So this is again for the sample of 100 tires, right? This is your standard deviation, sample standard deviation, S, sample standard deviation. So the question is, what is the best estimate of the average thread life in miles? Okay, so this is actually a typo. It should be in kilometers because all the numbers are in kilometers. So let's say kilometers. So what is the best estimate of the average for the entire population? So that means what is the best guess of the population mean? That's what this question is about. What is your best guess of the population mean? So our best guess, we don't know what population mean is. What we only have with us is the sample mean. So that is our best guess. So in other words, this question is talking about the point estimate. What is the point estimate of the population mean, which is sample mean? So best guess of mu, population mean, equals to its sample value, which is 80,000. Okay. Number 2, sample mean is the best guess of what? So if it's the mean, it has to be population mean, right? So sample mean would never be the best guess of population standard deviation, right? For population standard deviation, best guess would be sample standard deviation. So always for the parameter given, its sample value would be the best guess, or its sample value would be the parameter. So sample mean would be the best guess of the population mean. Number 3, sample standard deviation is the best guess, best point estimate of the sample value of the standard deviation. Is our best guess about the population standard deviation. So sample standard deviation can never be the best guess of population range, right? It cannot be the best guess of something else. It has to be the corresponding population value. Okay. And number 4, 100 graduates returned the survey. The average salary was 35,000 with a standard deviation. So this is the sample mean salary. This is the sample standard deviation, S, and 400 is the sample size. Sorry, 100. What's the best point estimate of the population mean? So if it's the population mean, it has to be the corresponding sample value, sample mean, 35,000. A recent Recently, university surveyed graduates of the English department for their starting salary. It's the same information. Interpret the result of 95% confidence interval. What does it mean by 95% confidence? That's what this question is about. What is this? Okay, so 95%, like I said in my lesson, 95% is the likelihood. It is the chance that the parameter is within the interval. So they're trying to estimate the average starting salary of a graduate from their department. So they're trying to estimate the population mean using a confidence interval, right? So if they are using 95% level of confidence, that means they are 95% sure that the actual average starting salary would be within this interval. So when you go through the responses, so A, population mean is not in the interval, wrong. There is a 95% chance that the computed interval does not, wrong. The likelihood that any confidence interval based on a sample of 400 graduates will contain the population mean. So the likelihood that it will contain the population mean is 95%. Correct. The population mean is in the interval. No. So see, this gives us the precise information. Okay. Right. Next page. Let me add next page. Okay. Okay, page number 2. Okay, so now we are moving forward with calculations. Confidence interval calculations. So number 6. A random sample of 85 group leaders and supervisors and a similar personnel revealed that on average a person spent 6.5 years on the job before being promoted. So 6.5 is the sample mean. Out of 85 they've sampled, they found out on average a person would spend 6.5 years on the job before being promoted. The standard deviation of the population was 1.7. This is important. So it says standard deviation of the population. Standard deviation of the population is 1.7. So this is not the sample standard deviation, this is sigma. Population standard deviation. Find 95% confidence interval for the population mean. So when you go to Excel, confidence intervals, so mean, right? So we need the sample mean. Let me go back, quickly read them again. 6.5, 1.7, 85. So this is 6.5, 1.7, 85, 95% confidence interval. And since, okay, this is very important, since you have the population standard deviation, 1.7 is the population standard deviation, you have to use Z, right? So you can click on preview or you can click OK, generate the output, whichever is fine, and then pick the closest possible. 6.139, 6.861, 139, D. Okay, so the confidence interval, if I sketch it, so this lower limit is 6.14, upper limit is 6.86, and somewhere in this range we have the actual average, actual population mean. So we are 95% certain that the population mean number of years spent on the job before promoting is between 6.14 years to 6.86 years. Okay. Number 7. Recently, university surveyed graduates. Okay, so this is the same information we saw before. 400 is your N, sample size. The average salary was 55,000. This is the sample mean. So out of 400, they calculated the average starting salary, and again it says population standard deviation is this much. So this is sigma, population standard deviation, and 95%. Okay, 55,000, 2005, 400. 55,000, 2,500, 400, and since 2,500 is the population standard deviation, we are using Z. Okay, so 54,755, 54,755 to, I think it's B. Yeah, B. Okay, so we are 95% confidence that the average starting salary of a graduate from English department is between 54,755 to 55,245. That's the idea of this confidence limit. Okay. And okay, this question is interesting because it's not giving you guys standard deviation, it's giving you guys standard error. So a survey of 144 retail N stores reveal that the average price of a DVD is 375 X bar with a standard error of 20. What's the 95? So standard error. So this makes us go back and think about what standard error is. If you remember, standard error was sigma over square root of n. Remember from chapter 7? This is called standard error, right? So this number equals to 20. So you have to do a little bit of algebra before actually going to MegaStat, because from this formula you have to figure out what sigma is. We already know what n is, right? So you can plug that in. Sigma divided by square root of 144 equals to 20. So that means sigma equals to square root of 144 into 20. So I'm going to do the math in Excel. So equals SQRT of 144 times 20, 240. Okay, so sigma is 240. So we have n, sigma, and mean 375. It's actually pretty big standard deviation there. So 375, 240, 144, and since this is sigma, standard deviation is sigma, which is population standard deviation, we are using Z. Okay, so 335.82, 414, 335.8 to 414. There you go. B. Oops, sorry. Wrong question. Okay. 335.8. This one. So C. Oh. Okay. Okay, technical difficulties. This one. Okay, right. So I did up to 8 and I want you to continue. Do number 9. I'm not going to do number 9. I'm going to show you one with the other side, when to use T, right? We talked about Z. Now let's talk about number 10. This is a case where we have to use T approach. So it says a student wanted to quickly construct a 95% confidence interval for the average age of students in her statistics class. She randomly selected 9 students, that's their sample size, their average age. So that means their average age means the average age of these 9 students. That means the sample mean, right? So their average age is 19.1. So this is X bar with a standard deviation. So this doesn't specify, or in other words, it can say their average age is 19.1 with a standard deviation. That means the standard deviation was calculated using those 9 students. She didn't use all students in her class. So this cannot be the population standard deviation, right? So if this is not the population standard deviation, this is obviously sample standard deviation. This is the sample standard deviation. You have to use T approach. Okay, so in most of the times, if it's the population standard deviation, it will be direct, very direct. It will directly say that population standard deviation is this much. If it doesn't say that way, usually it is the sample standard deviation. Okay, so let's go back to Excel. So let me 19.1, 1.5, and 9. Okay, so 19.1, 1.5, yeah, 1.5, and 9, and T. Still confidence intervals. Our level is 95, so T. So once again, because this 1.5 was sample standard deviation, we use T approach. Okay, so 17.947, 17.947 to 2025. Yeah, it's A. Okay. Right, so that's how it works. So we did both sides, Z and T. And then I'm going to show you a question for proportion. So far we talked about population mean, confidence intervals for population mean. So let's have a look at a question. Has to be, let's try this. Yeah, so this one has number 15. Okay, in question number 15. So it says college X is concerned about their employees making use of their email for non-business purposes. A random sample of 400 emails discovered 40 messages were non-business related. So that's their sample. Sample size is N. And then out of this 400, 40 were non-business related. Okay, so the 95% confidence interval for population proportion. So that means, so if you just think about population proportion, what is it according to the question? So this is what? This is the proportion of non-business related emails for this particular company, right? So they're interested in figuring out what's the proportion of non-business related emails in their employee basis, right? So what they've done is they have selected 400, a random sample of 400 emails, and discovered 40 of them were non-business related. So that is actually sample proportion, p hat. P hat is 40 out of 400. So that's all you need when you construct a confidence interval for proportion. So it's the other tab. So go to the next tab, confidence interval for proportion, this one. And all you need to provide is sample proportion. So sample proportion can be provided in the two numbers. So sample proportion was 40. So you can put 40 up here. You can notice the change over here. 40 over 400. There you go. So no choice between Z and T, no standard deviations, nothing like that. Just the sample proportion and then pick the level of confidence. That's it. So 0.071 to 12.9. 0.71 to 12.9. 0.71 to 12.9. I think it's this one. That's the closest. Yeah. So what does this mean? So this means if you draw the level, so lower limit is 7.1%. Upper limit is 12.9%, right? So the actual proportion of non-business related emails varies. It is between 7.1% to 12.9%, right? That's what this means. So we are 95% confident that the actual proportion of non-business related emails is between, what is this? Is between, okay, let me get rid of this first. Okay, so the actual proportion of non-business related emails for this company is between 7.1% to 12.9%. So based on the authority, the company's authorities, they can decide whether this is a higher rate, should they be alarmed, should they do something about it, or this is just a very lower rate. So we are still not going to implement any rules. So it completely depends on how you look at this number, right? Okay, so let's do number 16. A survey of an urban university, this is the population number, it's given, showed that 870 of 1,100 students sampled. So that's the sample proportion right here. Oh, what's going on? Okay, so, it's very difficult when you have to deal with the technology. Okay, come on. Yeah, there you go. Hopefully it will stay. Oh, come on. Okay, so this is the proportion, sample proportion, sorry. Students sample supported a fee increase. So out of 1100, 870 supported the fee income. And so this is a really good one. Actually, people use this in practice. People use these confidence intervals in practice to make big decisions, right? So the university wants to do a fee increment to fund some improvements to the student recreation center. So they want to know what percentage of students would be in support, right? So the actual proportion they want to look at is the proportion of students supporting the fee increment. So since they can't get the exact number, they ran a sample, and out of 1100 they found out 870 supports the fee increment, right? So based on this sample information, they are trying to build the confidence interval. So 99%. So they want to really make sure that they are precisely capturing the actual proportion. So 870 out of 1100, and we are going to change this to 99. Preview. Okay, 759822. Okay, 759. So this limit, lower limit is 759, 75.9% to 82.2%. So the actual proportion, this number, is somewhere in this range. So for the university, this is a good result, because for the university side, this means, okay, so the actual proportion of students who would support this fee increment is between 75.9% to 82.2%. That means more than 75% of the students will support this fee increment. So based on this result, if their sample is good enough, if their sample is representing the actual population, this result is accurate. So then they can go ahead and apply this fee increment. There will be lesser objections to this. They would expect lesser objections to this fee increment. So the answer 75 point, is that 75 point? Okay, so I think it's rounded to 76. So C is the answer. Okay, so I've discussed about the calculation. I have discussed what it means. So understanding both sides is extremely important. It's not just always about the calculation. Just think about what it means. What does it mean by building a confidence interval of the population mean or of the population proportion? Because that is going to give us a lot of idea about how these will be used in practice. Okay, and then the last section that I'm going to discuss in this video, this less practice session, is to talk about the reverse side of this calculation. So far what we have done is, for any parameter, mean, proportion, we built these two intervals, right? So we have our point estimate. Let's say it's for mean x bar, and then add all. So we actually didn't go into manual calculation of these numbers, right? We just simply used Excel. But what Excel is doing is it calculates the margin of error, add it to the point estimate, figure out the upper limit, subtract it from the point estimate, figure out the lower limit. That's what our result was. Okay, so now we are going to use the same idea in the reverse order to figure out what sample size should we need in order to build the interval we want. So we call it sample size estimation. This is actually a part of your lesson which I'm doing under the practice session. So you might want to add these notes in your notebook. So sample size estimation. So basically it's like, what sample size should I take order to land on the confidence level of my choice. So I want, let's say, so that's what we are trying to answer in this part. So I want a confidence interval with 95% level of confidence. Let's say that I need the error. So the complete idea is you can decide the width of your confidence interval. So do I want it to be very large? Do I want it to be narrowed? Right? So I'm willing to tolerate this much error in my confidence band. So you decide the level of tolerance. So my confidence interval, I want it to be this much of width. Okay. So for that, what should be the sample size I have to collect in order for me to tolerate this much of margin of error? What should be the sample size that I should collect? That is actually the reverse direction. So far what we have done is we have a given sample, we have the given sample mean and the standard deviation. Based on that, we were looking at what is the confidence level. So now it's the opposite. Based on the error, the margin of error, for this margin of error, what should be the sample size I need? Okay, right. So we can easily get this done in Excel as again. So these sub tabs, sample size for mean, this one, me use the mouse pointer, this one sample size for mean, and then sample size for proportion. Okay, so in both cases you can see E is the error. Capital E stands for the error, and you need to provide the standard deviation, and you need to provide what level of confidence you are willing to have. Okay, so let's have a look at an example. Just go back to the worksheet. I'm just going to do one question. It has to be the last page. Okay. Yeah. So, question number 18. A group of statistics students decided to conduct a survey at their university to find the average amount of time students spend studying per week. Average amount of time spent per week on studying. Assuming a standard deviation of 6 hours. So standard deviation is given. What is the required sample size? So in order for them to build this confidence interval, confidence interval, okay. So now this one is doing crazy things. What is the required sample size? What is your N? If error is to be less than half an hour with 95% level of confidence. So what this means is that when you think of building the interval, you are willing to tolerate 1/2 with around the point estimate. So this is the sample mean. We don't have that number, which is fine because we don't need it to do the estimation. So this width, come on, what is this? Okay, come on, cooperate. So this width is 1/2 or 0.5. So that's the tolerance. That's the error tolerance they are willing to cooperate. They are willing to have when building their confidence interval. So 1/2 width to the left of the point estimate, 1/2 width to the right of the point estimate. So E is 0.5. Standard deviation is 6, 95% level. So I'm willing to tolerate margin of error 0.5, standard deviation is 6, and I want 95%. Let me quickly check again. Yeah, 6 hours. Okay, preview. 554. Okay. Yeah, so it's D. So they need to, in order for them to build this interval with 1/2 width of margin of error, they need to at least have 554 in their sample. So they have to talk to at least 554 students, get their time spent per week, and that way they can build the confidence interval with the width they prefer. And if I do one last question, number 19, a group of statistics students decide to conduct a survey. Okay, same idea. Okay, let's do 20. It's the same question. So the mean number of travel days per year for the outside salesperson employed by hardware distributors is to be estimated. Okay. 90% degree of confidence is to be used. The mean of a small pilot study was 150. So that's the mean with a standard deviation of 14 days. If the population mean is to be estimated within 2 days, there you go. So that's your error. Within 2 days means 2 days to the right, 2 days to the left. That's the idea. So if this is your interval, this is the midpoint, point estimate, 150. So 2 days to the left, 2 days to the right, that's their willingness to, that's their tolerance of the error. So they want to figure out the confidence interval in this format. So in order to do that, what's the sample size necessary, right? So E is 2, error is 2, and let me quickly go back, check 14 days and 90%. Okay, so standard deviation is 14, confidence level is 90%. Okay, 133. So they need to get at least 133 in their sample in order for them to land on this setting, this confidence interval setting. Okay, right, so I haven't completed the whole sheet. I have done questions from here and there, but I want you to go ahead and complete the sheet on your own, and then write down any confusions, any places where you're confused, and talk to me during the office hours.